Welcome to the Small Wall Podcast.
This is the small wall. This is the small wall. The small wall. நான் கெட்டு போன குட்டி சுவரு. இதுதான். Your name's on the pink slip. You are in the small wall. They had no goodbye. You are in the small wall. That stopped working. You are in the small wall. Security walk first. You are in the small wall.
Hello, everybody. This is Srikant Devarajan coming to you on another podcast, the Small Wall Podcast. Today, we are going to see something very interesting in ML programming. Let's call it as federated learning. So let's quickly jump into that. I have a few slides. Then I'm going to show you a demo of an application that I wrote. So to start with, let's look into some of the ML challenges that we have, right? ML challenges, right? Whenever you start developing a machine learning application, you will face a lot of regulatory compliance, privacy regulation that create bottlenecks to train a model because you need data. Data comes with restrictions. And every organization have data silos. They prevent collaboration between organizations because, for example, take HR, right? HR might not, they are not willing to share data about their employees. And there is a huge delay in ML development. So it's going to take a long time to get data. Sometimes it never happens. Sometimes it takes a few months. Sometimes it's taken me about 7 months also. Never moves fast. It is very slow. And how do we resolve the problem? We resolve the problem by using something technique known as federated learning. So what is federated learning? The federated learning is a machine learning technique where multiple data sources collaborate to train a model. Each source uses its local data, keeping it private, and only shares model updates, the weights, ensuring privacy. It's very simple. Think of a school where there are many students taking their notes, right? That's local data to them, and they adjust their understanding based on their notes. That's the weights. Instead of sharing their complete their handwritten notes, they only share what they understood or learned. So that is exactly what federated learning is all about. What are weights? The weights are numeric values in machine learning model that determines how much influence different inputs have on predictions. Think of them like volume knobs on a sound mix board. Turning them up and down changes the final outcome. It's a very simple example. Next, I'll be explaining a very simple architecture. You look at that, there are two zones, a trusted zone and untrusted zone. The trusted zone contains three realms, data realms, or individual data sources. They are completely isolated from each other. All that they do is share the weights in a common zone, aggregation zone, where they are going to aggregate it and build one model, one global model from all these weights, and that is put in the untrusted zone, from where the ML application solution development happens. So as you can see here, let me animate this a little bit. And data comes from here, and the weights are aggregated here. And from there, it's transferred. The aggregated weights are built in one global model, and that is transferred to an untrusted zone where the trained models live. And ML solution development happens here. It's very straightforward. So here is a real example using AWS. We have three hospitals, hospital 1, 2, and 3, and they have their own own set of data, and they don't know about each other. And they do their local modeling that extracts the weights and uploads it into an S3 bucket there, secure S3 bucket on AWS, which is later sent down to SageMaker, which models it again and prepares a global model. And then we apply some encryption on the model, and that's put again on S3, which now these ML engineers here can use it right away and start developing their application. The best part in this is this ML team doesn't know the source, where it comes from. And each of the hospitals, they have no idea that they don't know that they are sharing their information across. It's completely, they are isolated. Only the weights are shared. By this, the privacy is maintained, and your ML application, you can start working on your ML application right away without worrying about the privacy laws and other issues that I spoke about before. So now I'm going to show you a demo of a quick application that I wrote. It's a quick and dirty application. I'll first explain the structure in GitHub, then maybe we'll go into the application. I will run the modeling, and you'll see how it works. So if you see here, right, this is my GitHub. I call myself Hypercoder. I have been having this site for some time. And first I have an aggregator here. It's a server that runs there. And this is the module that is in charge of building the consolidated model, aggregate the whole model. Let's call it, it's in a folder called aggregator. And uh, these are the records that I have for hospital one patient records. So you can see simply its age, and I'm predicting their diabetes, if they're going to have diabetes or not. That is the whole prediction. And this is the data set. And these are the models that's going to come. And there is an application that will run for you, and I'll show you the application, demonstration application that will really work. Now, quickly, let me jump to the application and I'll show you. So here we go. I have two windows here. The server is running on this side. And now I'm going to run the modeling application that's going to do three models and extract the aggregate. And we go from there. So this is just a screen that drives you to, you can read the screen. So first to start with, it is asking me to ensure the server is running. Yeah, of course it is running on this. I can see it on this side here. It is running. I'm going to press enter. Now I'm going to train the model for hospital number one. It's training as we see. I'm just putting some loss values and epochs to ensure the training goes well. And I have even a sample prediction there, and it is predicting it right. The patient that I put has got an 83% chance of getting diabetes. Next is I'm modeling hospital number two. Similar, but I put a nice healthy patient there. Chances are only 12.1%. And now I'm training model number three now, medium, 43% there, which is good. Now it is now training the weights. It's just listing all the trained weights there, hospital one, two, and three. And now we are aggregating a global model from all this. As you can see that the global model for the hospital is now ready. And I'm going to run that a sample application that is that you can see now here.
You are in the small wall. You are in the small wall.
So this is the app that I wrote quickly to test my aggregated model. It's a diabetes predictor. We are going to enter some age, glucose level, blood pressure, BMI, and family history, and see whether what's the percentage of a person getting diabetes. This is completely made up. The data is completely synthesized. Nothing is true about it, but just to demonstrate, I did this app. And I'll quickly walk through, just put 80%, 25. So glucose level is beautiful 90 in the morning. Blood pressure is 120 by 80. Just take the higher number. And the BMI is 22.5. And let's make it more diabetic. Predict the risk. So if you see here, this is using a common model instead of using the other three. As I demoed it earlier, the common model, it is using the global model.ph, as you see. So this is a very simple demonstration. And we don't, this is, as you see, that this is a conceptual idea. Next, I'll walk you through my code a little bit. I'll give you a very high level view of, maybe you can also check it whenever you get a chance. So if you see here, right, this is the server.py, right? The script is, the script sets up the central Flask server that powers this whole thing, the federated learning across hospitals. Each hospital train a local neural network on a private patient data and uploads it only the weights. So if you go to this hospital1.py, right, it's a neural network that I built and I'm training it on that. And it's got 5 features: um, age, glucose, BP, BMI, family history of whether they had diabetes or not. And I got an hidden layers of 16 to 8 to 4. And my output is sigmoid activation for the binary diabetes predictions and risk predictions. And I upload this PTH files in a location where the trained model waits from the hospital in a central location. As you can see here, the weights are here, hospital weights. These are uploaded after training here. It gets uploaded in this endpoint here, you can see. And that is aggregated with FedAvg. I use FedAvg, federated averaging method. Similar, you can go up and look in the server. It'll be federated average method that spits out this global dot model. I can't open it. Global model dot PTX. It checks for consistency in layer shapes. Each layer weights are averaged across the hospitals, resulting in one unified global model. One unified global model. Um, Other than that, diagnostic stats. I just added some diagnostic stats. For example, I did some sample predictions here, as you can see. 55 is the age, 180 is the glucose, very unhealthy person probably. So it's going to show you higher number. We saw it when I ran my model. And this architecture is very non-linear relationship while remaining lightweight enough for distributed training. Very, very simple to focus core principles federated learning. I hope you understood this. You can go into this and take a look at it. This modeling is not very accurate. I didn't try enough, but given the time I have, I just try to write something and typically the three of them similar. They are very similar. Just remember that the structures like the class types that you have for the neural network, they have to be very identical across all of them. So these three hospitals should use similar structures, similar class types. And when you go and do the aggregation also, the structure is very identical. So these are the issues that you need to deal with when you write a real application. Take a look at this. Anything, let me know. We can improve this, but it is just an example. And the project structure, one more time, the server application is here as aggregator, and these are the hospital 1, 2, 3 is the independent neural networks in three hospitals that is training the model. And these are the one model it spits out. Patient demo is the app that we saw. So with this, I'm going to end my podcast, I guess. It's been good doing this application because I also got to learn few neural network and other nice, beautiful aspects of programming. And in the next thing, we are going to see something very interesting. I've been dabbling with one more agentic AI for project management. So we will talk about it in my next podcast. Please subscribe to my podcast. And we have got exciting things happening in the podcast, and I've been working on it diligently. In the next episode, you'll see more, and I might also include a HR. I'm getting an HR expert to talk about how to deal with interviews and how to look at things, job approaching a job. And he'll be joining me in the next podcast. And until then,
You are in the small wall. You are in the small wall. If your name's on the pink slip, you are in the small wall. If the cut no goodbye, you are in the small wall. If your patch stopped working, you are in the small wall.